Hello students, myself Shraddha Agarwal from Holy Hearts Education Academy. Today I am going to deal with the second topic of the chapter solution, that is solubility and solid in liquid solution. Now the first question arises, what do you mean by solubility? Solubility is the amount of solute that is dissolved in 100 gram of solvent at a particular temperature, or we can say that at a constant temperature. On the basis of solubility, I can divide the solution into three categories. They are unsaturated, saturated as well as supersaturated solution. Unsaturated solution are those solutions in which more amount of solute can be dissolved in particular amount of solvent without increasing temperature. For example, if I am going to take out 100 ml of water and I am going to dissolve 1 teaspoon of sugar, it dissolves completely. And we know that it has more capacity to dissolve the sugar. So they are known to be unsaturated. Now coming to the saturated solution, if I am going to dissolve 4 teaspoons of sugar in 100 ml of water, it is going to dissolve, but on adding the 5th teaspoon of sugar, it does not dissolve and sugar reappears at the bottom of the glass. So that is known to be saturated solution. Now coming to the supersaturated solution. So saturated solution solubility increases by increasing temperature. They are known to be supersaturated solution. The best example of supersaturated solution is sugar syrup. Now coming to the second topic, that is solid in liquid solution. Once again I am going to remind you, solid in liquid solution means solid is going to act as a solute, whereas liquid is going to act as a solvent. Now we are going to see the molecular view, how solute dissolve in a solvent to form a solution. These are the solute particle. You can see that the particles are very attached to each other because of the high intermolecular force of attraction. When you are going to provide some amount of energy, the particles get apart from each other. As the particles get apart from each other, the amount of energy that you have given is known to be del H1 and the sign is given here positive. This shows that the reaction is endothermic. For endothermic, always del H comes to be positive. And what is del H? That is change in enthalpy. Coming to the solvent, you can see that the solvent particles are apart from each other because of less intermolecular force of attraction. Here some amount of energy is given so that the particles get apart from each other. And here del H2 again come to be positive, that means the reaction is endothermic. When solute and solvent particles intermix to form the solution, they will form, here the del H3 value come to be either positive or negative. This indicates that the formation of solution can be either endothermic or exothermic. Now what are the factors that affect the solubility of solute in a solvent? The first factor is like dissolves like, that is the nature of solute and solvent. Nature of solute and solvent based on the topic, that is like dissolves like. Here like means the nature of the solute and solvent. That means the polar solute dissolves in polar solvent, whereas the non-polar solute dissolves in a non-polar solvent. We can take one example of a polar solute, that is sodium chloride, dissolves in water. Water is also polar. At the same time, non-polar solute, that means anthracene or naphthalene, that dissolve in a benzene. They are known to be non-polar both. Hence, they both are soluble. Now the question arises, how can you know that the given compound is polar or non-polar? Just by knowing these two tricks, you can identify the substance is polar or non-polar. Polar compounds are always, mostly, not always, mostly heteroatomic. For example, H2O, NH3. At the same time, non-polar molecules are homoatomic molecule like oxygen, nitrogen. Hetero means different atom. That means a molecule made up of different atoms are known to be heteroatomic and they are known to be polar. Whereas a molecule made up of same type of atom are known to be non-polar. They are known to be homoatomic. Example, oxygen. And the second method is whether we have to know about the geometry of the compound. If the compound is unsymmetrical, then they form polar. If the compound is symmetrical, they form non-polar. Now, unsymmetrical means presence of a lone pair of electron in the central atom. Because of this, they had got the distorted geometry, and hence the compound comes to be polar. Whereas if there is no lone pair of electron in the central atom, the compound come to be symmetrical and inform the nonpolar compounds. Now, exception cases. Sugar and glucose both are nonpolar, but yet they dissolve in water. It is due to hydrogen bonding. So always remember, if any of the compound dissolves in water, only water, it is due to intermolecular hydrogen bonding. Whether it is glucose or sugar, it does not depend upon the nature. Now the second factor is temperature. On the basis of temperature, I can divide the solubility into three categories. The first one will be solubility increases with increase in temperature. Solubility of solute increases, and that type of compound are known to be endothermic. For example, sodium nitrate, potassium chloride, etc. Another type of compound where the solubility decreases with rising temperature. That means as you are going to increase the temperature, its solubility decreases. The compounds are known to be exothermic. For example, lithium carbonate, sodium carbonate, etc. Third come to be particular type of compound where the solubility does not follow the particular order, and this property is exhibited by the hydrated salt. For example, sodium sulfate decahydrate. When sodium sulfate decahydrate is heated above 32.4 degrees centigrade, it gets converted into sodium sulfate. But when it is going to heated below 32.4 degrees centigrade, it will form a hydrated salt. And the temperature, this 32.4 degrees, is known to be transition temperature. The last topic will be pressure. Pressure has no effect. Pressure has no effect on the solubility of solute in liquid, because we know that solid are incompressible. Hence, in this video we have learned about the solubility, types of solution based upon the solubility, as well as we have learned about the solid in liquid solution and its factor.